Hi everyone, let's do an application of the central limit theorem to sample proportions. This is problem number 88 from our textbook. It says a survey of all medium and large size corporations showed that 64% of them offer retirement plans to their employees. Let P hat be the proportion in a random sample of 50 such that of such corporations that offer retirement plans to their employees. Find the probability that the value of P hat will be, and we'll do B together. I'll let you do part A. So we need to do a little bit of setup. We need to determine, like, is it okay to use the central limit theorem? And if so, then we need to describe the sampling distribution of P hat. So let's go through and look at some important information here. It says all medium and large size corporations. So we're talking about our population size, N, right there. And it doesn't say specifically how many are in the population, but we know that this is America, and there are a lot of large and medium-sized corporations. So I'm just going to think of it as a lot. Next, they tell us the population proportion, and that's 0.64 because 64% of them offer these retirement plans. So 0.64 is right here. Next, we're going to take a random sample of 50. So our sample size, our lowercase n, is 50. All right, so we're going to use that, and we're going to decide, is it okay to use the central limit theorem? So we need to know a few things first. We need to know, did the data come from an SRS? Well, our textbook says that came from a random sample, and they don't actually use SRS. So we'll consider a random sample good enough. All right, good enough to be considered an SRS. Next, we need to know if the population is at least 20 times the sample size. So that would mean 20 times our sample size of 50. This is equal to 1,000, right? And is this less than or equal to n? Well, basically you have to think, are there more than 1,000 medium and large size corporations in America? Yeah, that's pretty safe to assume. So I'm going to check there. 3, we need to know that NP is greater than 5 and n times 1 minus p is also greater than 5. So our n is 50 and our p is 0.64. That equals 32. And yes, of course, that's greater than 5. Next, 50 times 1 minus p, so 1 minus 0.64 is 0.36, and that equals 18. And so yes, of course, that's greater than 5. So we can apply the central limit theorem. So here I can describe the sampling distribution of p hat, right? I know that the mean of p hat is going to be equal to p, and so that equals 0.64. I know that the standard deviation of p hat is going to be equal to this formula right here, p times 1 minus p divided by n. So if I plug in 0.64 for p, and then 1 minus p is 0.36, divide by my sample size of 50 and square root, I'm going to get the standard deviation, plug that in my TI, I'm going to have 0.0679. All right, so there's my standard deviation. And also I know the shape, I know it's going to be approximately normal. And that's because this NP and N times 1 minus P are both greater than 5. All right, so we're set up to use the central limit theorem. And we use the central limit theorem to describe the sampling distribution of p hat. That's all we're going to do in this part of the video. In the next part, we're going to actually calculate this probability. All right.